Okay, this is a good one. This is, it's like top of the line in what we're going to get in an AP statistics course. Claim is made. Platinum gas gasiver, a device they claim may increase gas mileage by 30%. Oh, wow, what a great claim. Here are the percent changes in gas mileage for 15 identical, randomly selected vehicles as presented in one of the company's advertisements. Great. So they give us 15, what are these things? Changes in gas mileage. So they measured the gas mileage of the car. They added the platinum gasiver, and then they did it again. Where the hell is that shadow coming from? I can't figure it out. It's annoying. Anyway. Then after they put the platinum gasiver in there, they measured them again, and that's the difference in gas mileage. I'm guessing that'll be for a tank. Doesn't really matter. Yeah, it does matter, because who gets 48 miles to the gallon? So I'm guessing it's a tank, but whatever. They don't tell us this stuff. But as a statistician, you should be thinking about this stuff. Construct and interpret 90% confidence interval. Estimate the, there it is, mean change in percent in gas mileage. Does the data support the company's claim? Use the 4-step process. I don't know what the hell that is. Use panic. So, we do not know the population standard deviation. Good. That's more realistic. We won't know the population standard deviation. So, all we're going to do is start with the problem. Now, usually you want to grab this thing first. Don't. You bums. Start with P. Parameter and population defined. We got a mean. And we're trying to figure out the mean. Where is it? There it is. Change in percent in gas mileage. Oh, that's the percent increase. Oh, I should have read the question, right? Mean percent change in gas mileage. Now, for these 15 cars? No. For all cars of this type. And that goes back to chapter 4. It was randomly selected from the population. Therefore, we can make a statement about the population of cars that it was chosen from. Like I said at the beginning, this is a good statistics problem. Parameter. Population. A, assumptions. This is when you want your gate calculator. So, to save us time, I have entered in all the data. I named it fuel. Put all the data in, bop, 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 bop. And now let's calculate our statistics. So I'll pause it if you haven't typed in the numbers. Yeah, right, nobody's typing them in. So just watch the magic. Statistics. Calculations. And we have one variable. Lists. One list. Fuel. Frequency list. Remember, use the frequency list when you have a one variable and a probability corresponding to it. We do not include categories. No. First result column C. That sounds good. Okay. All right. What do we got? We got an X bar. Is that important? I don't know. Let's write it down. X bar equals 29.43. Okay. We got a sum of X. Is that important? No. Sum of X squared, not for us. So here's the issue here. And I will be damned to hell if I don't mention that I had to look this up probably 5 times because, first of all, I can't remember anything. But second, because it doesn't really make a whole lot of sense to me. Which one do I use? So I know sigma refers to population usually. I know S refers to sample usually. I know this is a sample, so it seems like I should use 16.23. But then, well, then what is this? Because I don't have a population in this problem. And I will also be perfectly comfortable explaining to you that even though I've looked it up 5 different times over the last, 7 years, I still don't remember what the heck that number refers to, but we're using this one, 16.23. That's our SX, sample standard deviation, 16.23. See what else they give us. Number 15, we knew that. Quartiles, medians, I don't think we're going to get asked anything about that. So let's just be good with it. All right, so assumptions. Was it random? I don't know. Let's look for SRS. Nope, not there. So I'm just going to hope, I'm going to assume the quote randomly selected refers to SRS. Great. Independent. Well, we got 15 identical vehicles. So remember, 2 ways to go about it. We could assume that the gas mileage of one car has no effect on the other. I like going the number route. Let's assume this sample was taken from a population that was bigger than 10 times the amount of this type in the population. Okay, here's the hard part. Normal. So we don't know the shape of the population. It doesn't say it anywhere in the problem. And if we were going by z-scores and we saw that 15 up there, then it would just automatically be, we can't assume that the sampling distribution will be normally distributed. So here's what we have to do. We're going to have to look at one of the plots for this data. So let's see. Let's go to Data and Statistics. Let's look at the graph for fuel. Okay. Dot plot. Now 15 is right there on that important cutoff. Less than 15, we have to be a little more restrictive. 15 to 30, we have a little bit of wiggle room. So this thing, there's a little gap. It's skewed left, but it's not enough. Not enough to go on. And since I have my choice, I'm going to switch it. Let's look at the histogram. Oh, sorry. Let's look at the box plot to see if there's any outliers. Good. No outliers. So in a 15-minute free response question, I don't think it's going to be held against you. I'm very, very, very confident it's not going to be held against you if you don't do 1.5 times the IQR and check blah, blah, blah. Let's just look at our graphs. It's a good chance it's provided to you, but I don't know. We'll see. Look at our graph. No outliers present, but let's look at one more normal probability plot. So on this one, remember you're looking for, is the data roughly linear? And sure does look linear. There's a little curve at the end, but I mean, my gosh. The low numbers have a negative z-score. The higher numbers have a positive z-score, and then the right around 25-ish, maybe 30-ish. It's at the center of that curve. So, normal looks good. So we're going to say no outliers. We're going to say NPP, stat language, of course. Normal probability plot is roughly linear. And we're going to say it's safe to use T procedures. So, depending on time, if you have the time, I would sketch out a real quick one of those graphs. Box plot's the easiest, you know. Sketch it out. There we go. There you go. Make a dot at negative 2.4. Make a dot at 10.8. Make a dot at 33.7, 44.6, 48.3. Have a nice scale at the bottom. It doesn't need to be a rectangle. My God, just sketch it out. We're good. All right. Anyway, PAN. Now, haven't done one of these on my video yet. So, what confidence interval are we going to use? Usually at this point I would write down the name of the interval first, but I'm going to go to the menu first. So, stats distributions. We are, confidence intervals. We are doing means, which means we're going to use one of the first 4. Well, we only have one sample, which means we're down to the first 2. It's definitely a T interval, so we're going to use that one. Data input method. What the heck? Data, well, what's my other option? Stats. So, stats is, are you putting in the numbers? Are you putting in sample size and everything else? Or is this interval coming from a list that you put in a spreadsheet? It's coming from a list that we put on a spreadsheet. Let's keep it as data. So list, what data are we using? Fuel. Frequency list, I don't know what that is. And, I'm kidding, I do, but we're doing a 90% confidence interval. So let's call it 0.90. So in this case, boom, I did all that stuff, but I'm not going to do that yet. I'm going to say I'm using a T interval for means. Great. I'm going to show the formula. It looks like we did need this number. So, I don't remember what it's called in the formula. Critical value, right? Critical value plus minus t-score. Oh, I gotta calculate the stupid t-score, don't I? I wish it was listed somewhere. Is it listed anywhere? It's not, but margin of error is listed. This might be good enough. Oops. So margin of error is 7.38. Now, to prove to the grader that I know where this 7.38 comes from, I'm going to call that T star times sample standard deviation over square root of sample size. Now, yes, even though this is a sample standard deviation, you still divide it by square root of sample size to get the standard deviation of the sampling distribution. Boom, did it. I interval calculated. Let's see where is C lower 20. Oh crap. C lower 22.05. Upper 36.82 if you round. And then you make your claim. I am 90% confident that interval from 22.05 to 36.82 contains true what? Percent change in gas mileage. I wrote all the mileage. I wrote all the key jargon up in the first P step, so I'm good. Oh, and then before you break your arm patting yourself on the back, did you answer the question? Blah, 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 blah. Does this data support the company's claim? The claim was they may increase gas mileage by 30%. %90 confident that the true percent increase in gas mileage is somewhere here. Does this support the company's claim? Yeah. 30 is within that interval. Any number in this interval is something that we think could happen. So, yes, since 30% is within the interval, our interval, we believe the claim is supported. All right. As always, I'm hoping I was right.